Okay, let's do our assumption checks for our examples in Chapter 10 on comparing two populations. So our first example was the dependent sample setting, and we had the differences between, we wanted to compare contractor A's bids to contractor B's bids to get an idea of the mean difference in bids. So we use our difference column because we're in the dependent sample setting. So we took the column in our data set called contractor A minus contractor B to get the difference column, and then did our QQ norm command on that set of differences. And we get the resulting QQplot here. Now this is a really small data set. There are 10 observations, and so that is definitely a small data set. So we need this thing to look, pretty linear, like these observations come from a unimodal symmetric distribution that's not too skewed, doesn't have major outliers in it. So I know it's not a perfectly straight line, and it's never ideal when you just have 10 as a sample size. So we just kind of need to do what I said before and like squint and see if we see a major shape being made. This actually doesn't look too bad for me, especially considering that it looks like we have two sets of repeated observations here. So, which I'm not surprised about because I think this is made up data. I got this one out of an old textbook. Anyway, so it looks like if it was going to be an S shape, this point would have been down further. This one might have been up a little bit further. I'm not sure this is actually making a shape. So I'm going to say that it doesn't look too skewed or like it has major outliers. It doesn't look too far from linear. So the QQ plot is not perfectly linear. But I don't see a clear shape. The CLT, the central limit theorem, may work for us here. And get us the assumption that the sample mean has a normal distribution. Now in practice, I would use other tools in my toolkit. I've got 3 or 4 hypothesis tests that I like to do on samples like this that get me actual p-values where the null hypothesis is normality and the alternative is not normal. And so you don't have those tools in your toolkit. That's beyond the scope of this course. So in the absence of other information, what I want you to keep in mind is that I just want you to know how to read these QQ plots. We might not always come to the same decision as each other on what shape we see or whether it's enough for the central limit theorem to kick in. However, I want you to know some of the basics, like if the observations are from a normal distribution, it's going to be linear. If you see a definite shape being made, it's probably not from a normal distribution, and then those loose cutoffs for sample size requirements for the central limit theorem to kick in. All right, so keep that in mind as you're going through your examples and working through your practice homeworks. Okay, so we have our 2 QQ plots since we're in the independent sample setting, one for Colorado and one for Texas on the prices of Zocor. And we have small sample sizes, they're both less than 20. So we really need for these to be linear. Now, when you look at these QQ plots, you're probably thinking, that doesn't look linear to me. However, when I squint, I don't see, a glaring evidence of a shape. Like this looks like kind of like repeated observations right here, and same here in this top 2 QQ plot. Okay, and so that's probably distorting what we're looking at a little bit. If I draw a line down through here, it's not too bad, except for, like maybe that guy right there, right? Okay, I don't see a glaring U shape, a glaring S shape, something like that. Same situation down here for Texas. The QQ plot, I see some repeated observations that make it look a little bit like it has that stair-step pattern in a couple places. But other than that, I don't see like a glaring evidence of a major shape, okay? I would be hesitant to trace it like this because I'm missing a whole bunch, all of them here, okay? And I'm going towards just the two little points in the ends. So these small sample size QQ plots are really hard. So to be quite honest, what I did was I actually did some of those hypothesis tests I talked about to check for evidence against normality before I made my decision about how I was going to interpret this for you. So, and you don't have that, and that's not quite fair. So don't worry, I won't be putting pressure on you to come to the exact same conclusion as me, especially on these more difficult ones, but I do want you to know how to talk about a QQ plot. So keep that in mind. All right, so I'm going to say that neither plot is perfectly linear. But I don't see glaring evidence of a shape. All right. Because the plots are not too far from linear, and sample sizes are close-ish to 20, we'll assume for this example's sake that the CLT will get us that the sample means have a normal distribution. Okay, now make sure that you're doing your practice homework for chapters 9 and 10 because you have lots of other examples on QQ plots there, so you can get really good at it. And that's it for this lecture.